Hello everyone. So welcome to like a quick demo of something that I've been recently hacking. So what's the idea? Okay, let's talk about what's the problem. The problem is that, I really don't like the way we send money even after crypto is here. And I really don't like the properties that public blockchains offer when you pay. So, for example, recently I was paying to a small charity, and I asked them for their address, and I was like, why am I asking them for their address? And then I was like, oh, everything that I do is also public, and that started making me think, that why don't we have a better use for sending money over the internet? So, if you look at the current public blockchains, the problem is that if Alice pays Bob, firstly, Alice asks Bob's address. So they get to know who Bob is. And then when Alice pays Bob, then Bob also gets to know who Alice is on the chain, right? So both of them know each other on the chain, privacy leaked. Now, any third party can come to this blockchain and can see all transactions that Alice made. They can also see that Alice and Bob interacted, and they can do complete surveillance on both of them. And that's not really nice because it's already worse than whatever already exists in the current financial infrastructure, right? So it's bad, and we need privacy here. So that's where like I started hacking something I'm calling Aztec Pay. The idea is that uh, Alice, rather than asking any address from Bob, pays to some ephemeral account. So Alice generates an ephemeral account and pays to that on Aztec, and it's an encrypted transaction. So when it lands on Aztec, it looks like just random like data. You can't figure out what Alice did here. And then they send a payment link with all the information of this ephemeral account, and then Bob can do another encrypted transaction from this ephemeral account that was created, and they can receive their funding back, right? And the transaction that Bob does to claim this money is again encrypted. So the properties you get is that Alice doesn't get to know who Bob is on Aztec. Bob doesn't get to know who Alice is on Aztec. So both of them have complete privacy from each other. They only did what they wanted to do, like just a simple transaction without leaking every detail about them. And then the encryption uh, in Aztec protects them from third-party surveillance. So now when a third party looks at the Aztec blockchain and they look at, oh, this is an encrypted transaction, this is an encrypted transaction, they can't figure anything out from it. Like they can't figure out Alice's and Bob's business interaction, so you don't have third party surveillance. So that's like a quick idea of how it works. How the link works is pretty simple. Alice pays to an ephemeral Aztec account. It encodes all the detail of this account in a link. Then this link is sent through some encrypted channel, signal or something like that, and then Bob claims their fund privately from this link. So that's how it works. Now let's go to the demo. Cool. So let's come here, Aztec Pay. Okay, so right now what's happening is the app is being initialized, an embedded wallet is being initialized, and yeah, that's what's happening. And we be using so like an account is being created for you inside the browser. It's being deployed to Aztec's devnet, and we're using the fee paying contract to sponsor all the fee dues, like which is the gas equivalent on Aztec required for this process. So it's gonna take 2 to 3 minutes. But till then, I can talk about some other cool parts about it. Is that with an integration of something like near intents, it eventually allows you to take money on any chain and basically send money to anyone on any chain. Like they don't even get to know that they're on Aztec. You will see that in the demo, where we are able to claim this money back on Basepolia. So you don't have to install an Aztec specific wallet. You don't even have to know that you're on Aztec in order to be able to use the specific application. So let's look at the console, what has been happening. Okay, like a proof was generated and now the transaction is being sent. One quick thing is that it's all happening on your browser. There's no third party where your account is generated. All the proving happens on your browser. Like it's completely private in that sense. Like there's no server that's doing proving for you. Like all in your browser itself. Cool. So our account is initialized. Now there's a faucet that we're using, but in a production version, you would have something like near intents through which you can bridge money into this application. Right now we're just gonna faucet some USDC into it. But yeah, in a real version it would be something like bridge with near intents, bridge with something like that. Oh, sign in with your MetaMask, you sign in with your Phantom wallet, send money from any chain, and then you see your USDC inside this application. So let's see, we have requested the fauceting here. You can also open the logs, they are always fun to see. Cool, so the request has been sent. Oh, cool. Looks like pretty soon you're gonna see the balance. Okay, yeah, here it is. So now we have 1,000 USDC and it's all shielded, right? So it's all private. It's all encrypted on Aztec. No one knows you have it. So now let's say I wanna pay Bob 100 USDC. So I say I wanna pay 100. I say welcome to the encrypted computer as like a small message to them, and then I generate a payment link. Now what's happening while I'm generating this payment link is that it's again doing a shielded transaction, an encrypted transaction to a random ephemeral address that has been generated in the browser. So you created an address like a new account and you're sending funds to that, and that's the account from which now Bob will claim their funding from. So right now if we look at the console, yeah, like the proof generation is happening. Proof generation happened, the transaction has been sent. So pretty soon it should be mined on Aztec, and like we should see a link. Let's see. Okay, cool. So we now have the link, and now I can send this link to anyone over a channel like Signal, and they should be able to claim their money. So for example, I come here and I open this link. Let's say I got it from Signal, from friend. Okay, so now it says that it's initializing an Aztec client, and now what's happening is that this link contains all the details of the ephemeral account from which Bob can claim their money, right? So that's the thing. Like right now what's going to happen is now it's checking that okay, here's an account from which claims to have my funding. It synced all the private state for it and found okay, there is some $100 for me in it. So now what you can do is that you can now take this money out on any chain and address of your desire. Right now I have like hacked my own private bridge between Aztec and Base, but ideally this would be something like Neo, where you should be able to basically pay on to a near intent bridge and get money on any address. Right now we're gonna just do Base Sepolia. So I can come here, I have already have the Base Sepolia chain added for me in MetaMask. I'm gonna say let's receive some funding here. Let's receive my USDC. I've already added the token, it's called BUSDC. I have 0 BUSDC right now. On how to add this specific token, like this will show up once the claim is done. It will give you the address of the token itself to add. So now what's happening is that the bridging is happening. So firstly, you got 100 USDC privately. Now you are sending this 100 USDC privately to the bridge. And then the bridge is gonna give you your money in your public account on whatever chain you want. So ideally that will happen through something like near intents. Right now the step one is that it's deploying the claim account, because this account needs to be deployed first, this ephemeral account, so that you can take the money out of it. Aztec has like fee abstraction in a way. So we have these things called fee paying contracts which can like pay fees for transactions. So right now that's why we have this gasless experience. And Aztec also has account abstraction, which means you can basically create accounts that have any sort of logic in it. So right now that's what's happening. Like our claim account is being deployed. It's a first class citizen. So it's gonna take like some like 30 more seconds probably for the account to be deployed. Let's look at the logs. And all of this gets faster and faster. So right now, like we are on DevNet, but as we shrink down the block size to 6 seconds, it's gonna feel more and more like Ethereum like latency. So you can develop all Ethereum applications with Ethereum like latency in it. Okay, yeah, so basically so here the log says that the notes, like the account has been done. Now what's happening is we are transferring the money shieldedly to the bridge. So now again, once this shielded transaction is done, which is like again an encrypted transaction, then the bridge will check for it and then it will send you your money on base. So yeah, as proving gets faster and better, I think it's already quite faster than what it is in the browser for a mobile application. But as the proving gets faster and faster, and as our block times go down and down, like transaction latency would just feel like whatever it feels like on Ethereum. So you can have all Ethereum applications completely encrypted, and since it's stage 2, you get all of Ethereum's security. Yeah. So that's the cool part. So cool. So the transaction has been sent to the bridge. And now what's going to happen is that as soon as this transaction is sent to the bridge, now the bridge starts looking whether it has been sent some money or not. It's the bridge recognize that okay, I've received a USDC and the payment is complete. So now when I come and look here in my MetaMask, I see, oh, I have received my 100B USDC completely privately. I don't know the address of the person who sent me. I know the person who sent me this link, but I don't know their address and they don't know mine. So that's a cool part, and it was all done encrypted on Aztec without anyone, without the fear of any third-party surveillance. So I think that's the UX through which you will ideally onboard more and more people onto crypto. You're gonna send them these links to pay as the block times go slower and slower, and the latency gets better and better. It should ideally be all doable, like a 10-second or a 12-second scenario. That's where like it all starts looking like even better in terms of UX, but it's already really nice for business payments. The next things that I'm trying to hack upon is to lock these funds behind like ZK email proofs. So right now anyone with the link can claim the funds, but ideally you can also use ZK verification where like someone who has access to a specific email can access it. So now you can do payroll with it. You can already do payroll with it. You can just send all your employees these links, but you can have this extra measure where anyone who has the email of have a specific email is only eligible to take it. You can even do ZK passport proof where like only someone from a specific country with a specific name is able to take funds out of this, and keeping it all private. So yeah, it's just the like surface. I'm just scratching the surface here. But yeah, if you have any questions, feel free to DM me and ask me around.